Electric vehicles are about to become a thing of the past, courtesy of Toyota's all-new engine type, which is completely unheard of. This new engine that Toyota has been working on is said to be the most eco-friendly engine in existence. So, buckle up and get ready for a complete turnaround in the world of cars, as we explore Toyota's new engine that will challenge the entire EV industry. The engine that Toyota is working on is, believe it or not, a water-powered engine, which is relatively similar to their hydrogen-powered internal combustion engines, such as the 1.6-liter hydrogen 3-cylinder they have recently developed. Throughout history, water engines have always been one of the greatest aspirations of the entire car industry, as they promise huge benefits over regular engines and EVs. There have been countless attempts at making water-powered engines viable and reliable for day-to-day usage to no avail. That is exactly where Toyota is about to jump in with their all-new water engine. Unlike most previous attempts, which were made with limited budgets, Toyota has proper funding and can test the engine in all possible conditions. How does the water engine actually function? The engine itself is, for all intents and purposes, similar to an HHO generator with only a few minor differences that make it better suited for daily usage in vehicles. It is very similar to the hydrogen combustion engine found in the Toyota Yaris GR, except that instead of using already processed hydrogen, the engine processes it and separates hydrogen from oxygen by creating a chemical reaction. The process of powering the vehicle is where the similarities between hydrogen combustion engines and water engines start. After it is separated from oxygen, hydrogen is sent to the engine where it combusts, similarly to compressed natural gas. As long as you have access to distilled water, you will be able to refuel it, and it will also cost you next to nothing. Also, there will be much less need for extracting oil if the engine goes mainstream. The only real branch of the entire industry where fossil fuels might still be used is in heavy machinery or large power production units. Furthermore, there will be no need for extracting rare metals from the earth, which is one of the most environmentally damaging processes in the entire car industry at the moment, as it directly pollutes both water sources and the surrounding soil, making the immediate area uninhabitable. If we compare water engines to hydrogen combustion engines and EVs, which are also marketed as zero emissions, we see that they are far superior in this regard too. Storing water requires little to no effort, whereas storing hydrogen alone requires much more thought, specific conditions, and above all, much more money, while also being significantly more challenging for the environment. Hydrogen in its pure form is a gas that is extremely hard to contain and can easily escape from a vehicle's tank if there are any irregularities. This means the tanks need to be armored, constantly monitored, and regularly maintained. A fuel tank for water-powered vehicles can hypothetically be virtually any plastic container. Furthermore, storing hydrogen outside of the car itself is difficult, as it requires ideal temperature conditions, needs to be completely static, and must be indestructible, which once again costs a lot of money. In contrast, distilled water can be bought in any well-stocked supermarket, or if you know basic chemistry, it can be produced at home. Also, acquiring hydrogen in its pure form is an expensive process combined with the numerous problems surrounding the storage of the gas itself. This is why hydrogen has not yet caught on and probably never will. Producing and storing hydrogen costs a lot of money, which raises the price of the gas itself for the consumer. This makes us question why you would even buy hydrogen cars if they are both more expensive to buy and run compared to EVs and fossil-fueled vehicles. So even though they are very green and logistically simple to use and run in theory, the question remains, are water engines actually daily usable? Yes, they are. First of all, they are not underpowered at all, as some might believe. A water-powered engine is on par with most gasoline engines, and in theory, they can be made more powerful than regular internal combustion engines, as they can generate up to 3 times more energy compared to gasoline engines. They are also much safer than all other engine types, as no highly combustible fuel is constantly stored inside the car. So there is no need to worry about the car catching fire or exploding. They are also very easy to produce, as their relatively simple mechanical designs are only slightly more complicated than regular gasoline engines. They are much simpler and cheaper to produce than both EVs and hydrogen vehicles. Due to their nature, they would be a perfect option for motorizing countries that are not well developed and are not rich with oil. In fact, for this reason alone, an Iranian scientist decided to convert his Peugeot 405 to run on water, and actually succeeded. The scientist, Aladdin Qasimi, managed to produce a fully functional conversion for his old car, and turned it into a true technological marvel. Imagine what Toyota could do with proper funding if a person could make a daily drivable water-powered car. Apart from being easy to produce, water-powered engines are also extremely economical compared to both gas-powered vehicles and electric vehicles. Casimi's own 405 averaged between 30 and 40 miles per gallon of water, which is fantastic because the base petrol engine used in the car could never achieve such high figures. This means we can hypothetically see water-powered engines that can do 80+ miles to the gallon without being underpowered, which makes the cost of running such cars even lower than initially believed. However, since there are no mainstream versions of the engine type and no other car manufacturers actively working on it, we have to ask ourselves, are water engines the future? Well, hypothetically yes. Water engines might just be the future of vehicles. However, the conclusion is not that simple, as there are a myriad of issues that water engines have experienced in the past. First, there are logistical issues. Although the infrastructure would need little to no adjustments, the engine technology is still highly experimental. Most of the so-called functional prototypes have been very unreliable, and their daily usability has been mediocre at best. Furthermore, even though using water as fuel might seem like a good idea, the fact that it gets divided into hydrogen and oxygen makes us question the safety of the car itself. As mentioned, hydrogen is extremely hard to contain, and even a small leakage in the system can be highly dangerous and even fatal. Plus, even if Toyota were to make a reliable and safe water-powered car, who is to say they would not face opposition from lithium mining companies, battery producers, and most notably, oil companies? By using water as a fuel, we would almost completely mitigate the usage of fossil fuels in day-to-day life, heralding a seismic shift not just in automotive technology, but in global energy politics and environmental strategy. This transition would represent one of the most profound disruptions to the status quo since the Industrial Revolution, fundamentally dismantling the economic and geopolitical power structures built over a century around oil extraction, refinement, and distribution. The very prospect of a car powered by the most abundant substance on Earth poses a significant challenge to industries whose entire business models are predicated on the scarcity and controlled distribution of energy sources. Therefore, as much as we as consumers and environmental advocates would love to see Toyota actually going through with the development and mass production of this engine, we are not sure that such a paradigm shift is going to happen anytime soon, if ever. The challenges here are not just technical. They are deeply entrenched in the global economic fabric. Developing a functional water-powered engine is really just the first hurdle. The next battle for market acceptance would be fought against a formidable coalition of entrenched interests. Lithium mining companies, battery producers, and the entire ecosystem built around electric vehicle manufacturing have invested hundreds of billions of dollars into establishing electric vehicles as the future of transportation. Similarly, the oil and gas industry, with its immense political influence and lobbying power, has a vested interest in making sure transportation stays tied to hydrocarbon-based fuels for as long as possible. The introduction of a technology that could make both of these huge investment pathways obsolete would almost certainly be met with fierce resistance. That could range from sophisticated disinformation campaigns and political lobbying to real challenges in setting up a new fueling infrastructure that, while simple in theory, would have to compete with deeply subsidized and well-established industries. So even if Toyota were actively and successfully working on perfecting this engine, they are most likely doing it in absolute secrecy, protected by layers of corporate confidentiality and strict non-disclosure agreements. This level of secrecy is not just prudent, it is necessary to protect the intellectual property and the overall viability of the project from being exposed too soon. Announcing a world-altering technology like this too early could invite overwhelming corporate and political pressure that might stifle innovation before it even leaves the laboratory. It could also concern investors who have significant stakes in Toyota's current and future strategies.